Hi friends, let us look at this problem from 2014 Advanced. Here we are given three positive integers a, b, c such that b by a is also an integer and a, b, c are in geometric progression. What does that mean? A, B, C are integers and b by a is an integer. That means the ratio is an integer. Right? A, B, C are in geometric progression. That means the common ratio b by a, c by a, which should be same, and that should be an integer because b by a is an integer. And arithmetic mean of a, b, c is b plus 2. Then what is the value of this expression? A square plus a minus 14 by a plus 1. So basically we should be able to calculate what is this a. Right, given this condition. These are positive integers and the ratio is also an integer. And we have this good condition. The arithmetic mean is equal to b plus 2. Let us use these conditions and try to calculate what is a. Right. So because these are in geometric progression, these three numbers are in geometric progression that is already given, right? Let's call them as a, ar, and ar square. Right. Now, all three are positive integers only. What is the average of these three? What is the arithmetic mean? It is given b plus 2. What does that mean? A plus ar square by 3. Right. This is the arithmetic mean. Should be equal to b plus 2. What is b? B is again ar. Should be equal to ar plus 2. Let us just simplify this. Then a plus ar square should be equal to 3 times ar plus 2. That is 3ar plus 6. What does that mean? If you take this 3ar to this side, it becomes a minus 2ar plus ar square equals 6. That means a times r square minus 2r plus 1 equals 6. That also means this is r minus 1 whole square, right? R minus 1 whole square. A into r minus 1 whole square equals 6. Now, a is an integer. At the same time, r is also an integer. That is what that is given, right? The problem a, b, c are integers. And b by a is integer means r is also an integer. Now, this is r minus 1 is square of an integer and a is also an integer. How many squares? So, and the product of this is actually 6. And then what are the various options of r minus 1 squares? Right, this is the square of an integer, square of an integer. So at max we can have 4 or we can have 1 because other numbers below 6 are not squares. Right. And this is also an integer, this is also an integer. Obviously both are positive. Then the product of this has to be 6. So both has to be less than 6. And at the same time, this one has to be a perfect square. The perfect square, there are only two options. One is only 1, the other is 4. And if this is 4, r minus 1 square is 4, then a cannot be an integer, right? Because this becomes 6 by 4, which is 1.5. A is not an integer. So only option is r minus 1 square should be equal to 1, right? That is the only option. Then a becomes 6. Then r becomes 2. Right. This is the product of two integers. Please note product of two integers. And this is actually a perfect square also. So this can be either 1 or 4. If it is 4, then a cannot be an integer. So r minus 1 square should be 1. That means a equals 6 and r equals 2. Right. Now we found out what is a. A is 6. Let's directly substitute in this expression. 6 square plus 6 minus 14 by 6 plus 1. Right. 36 plus 6 minus 14 by 7. This becomes 28 by 7, which is equal to 4. Right, guys? It's a simple problem. Just that we should be able to write this simple expression and deduce that r is 2 and a is 6. Thank you, guys.